Hi guys, this is Dr. Manjunath Chenapkot from Anveshana Academy, Bangalore, India. Dear students, in the previous class we discussed one numerical on diesel cycle. Okay, so today I will move towards next numerical on diesel cycle. Okay, so we will try to solve next numerical on diesel cycle. Okay, so this is the diesel cycle efficiency equation what we have derived in the previous class. Okay, so now I will move towards next numerical, that is second numerical on diesel cycle. First I will read the problem, then I will solve this problem step by step. Okay, so the compression ratio of a compression ignition engine working on the ideal diesel cycle is 16. That means what? He has given compression ratio for a compression ignition engine, that is equal to 16. Full stop. The temperature of air at beginning of compression is 300 Kelvin and the temperature of air at the end of expansion is 900 Kelvin. Full stop. Determine first one cutoff ratio, second one expansion ratio, third one the cycle efficiency. This is the problem what he has given. So dear students, what we have to do? Before solving the problem, first we need to read the problem twice or thrice. Okay, we need to understand the problem properly. Then we have to do proper analysis and we have to list out the given data. Then we have to list out the relevant formula for the particular problem. And if required, we need to draw some schematic diagram or PV diagram or TS diagram for a particular problem. Okay, that we can see now. So what I will do now to solve this diesel cycle problem, what I have to do, I need to draw PV diagram and TS diagram for diesel cycle. What is PV diagram, dear students? That you already know. This is what PV diagram: 1 to 2 compression process, adaptive compression process, 2 to 3 heat addition process at constant pressure, then 3 to 4 is expansion, that is nothing but adiabatic expansion process, 4 to 1 is the heat rejection at constant volume. Heat addition at constant pressure, P is equal to constant, whereas heat is getting rejected, that heat rejection is QR at constant volume. The variation of temperature can be seen in the TS diagram, temperature versus entropy diagram, dear students. Okay, so this is the problem. To solve that problem, we need to draw the PV and TS diagram. So PV and TS diagram I have drawn. Okay, what I'm doing now, I'm going to solve this diesel cycle problem. Okay, so some important terms will play a very important role while solving the numerical. So for that you should know the working principle of the diesel engine. So piston is moving from BDC to TDC, TDC to BDC. Okay, so that is nothing but compression expansion will takes place here now. So what we are doing, we are going to supply certain amount of fuel to add the heat to the air mixture, to the compressed air. Okay, this is what, this is required. Okay, that I already explained in detail while working principle of diesel cycle. Okay, but these basics are very important. To solve this numerical, just we have to understand, because he is asking cutoff ratio. What is cutoff ratio? We already know when the piston is at point 1, right? It is a BDC, you can call it as a 0.1. So that is nothing but what? 0.1. When it's moved from 0.1 to 0.2, that means what? BDC to TDC, you can call it as a 0.1 to 0.2. That means what? Piston is moving from BDC to TDC. Hence, whatever the air sucked into the cylinder, right, it will be get compressed. That is get compressed, but there is no heat transfer during the compression. Hence, we can call it as a adiabatic compression. Okay, with the help of this now adiabatic compression process, what I can do, I can calculate the compression ratio. Compression ratio we can calculate, that is nothing but what? RC is equal to volume of air at point 1, then volume of air at point 2. One thing, and we are going to add heat, right, at a constant pressure P at point 2 and 3. That means what? Pressure at point 2 is P2, pressure at point 3 is P3. So P3 is equal to P2. At constant pressure we are going to supply a certain amount of heat. Because of that heat, the expansion will takes place. With the help of this expansion, what we can do? We can calculate the expansion ratio, that is V4 divided by V3 is equal to what? Expansion ratio. I will write it here RE. That I can calculate with the help of what? Again PV diagram. Where I can get this pressure variations with volume, that I can get it with what? Piston and cylinder arrangement. Here it is the crankshaft. With the help of the crankshaft, what I can do? I can calculate the compression, suction or heat addition process. Now once it done, right, once the expansion takes place, right, it is going to do some amount of work by supplying certain amount of heat. Hence we are going to get the efficiency, cycle efficiency. That also I can get it here now. So with the help of this schematic diagram or working diagram of the engine, what we can do? I can draw the PV diagram and TS diagram. With the help of that PV diagram and TS diagram, what I can do? I can solve this numerical step by step. How it is, that you can see here now, dear students. Okay, so what all things he has given? Now cycle efficiency. First I will try to understand the given problem thoroughly. What is that? To calculate the cycle efficiency, we should know the value of what? Compression ratio, cutoff ratio and specific heat ratio. What is compression ratio? Already I told you, dear students. Compression ratio is RC, cutoff ratio is rho, then specific heat ratio is gamma. So if I want to calculate the cycle efficiency, because in the problem one determination or one finding is efficiency, that efficiency I can calculate when I know the value of compression ratio, that is RC, when I know the value of cutoff ratio, that is rho, when I know the specific heat ratio, that is gamma, dear students. So you can see here now, to calculate the air standard cycle efficiency of a diesel cycle, we have the equation, that is 1 minus 1 divided by gamma into T1 into bracket rho to the 4 of gamma minus 1, rho to the 4 of gamma minus 1 bracket divided by T1 into RC to the 4 of gamma minus 1 bracket rho minus 1. This is the equation. To calculate this efficiency, what I should know? I should know the value of gamma. So that gamma is nothing but what? Specific heat ratio. So that gamma is equal to what I can do now? Cp divided by Cv. Okay. So now I should know the value of what? Gamma. Fine. Next, RC. What is that RC? RC is nothing but what? Compression ratio. We know already. RC is equal to what? V1 by V2. Where I can get it now? This value I can get it from the PV diagram. Okay, one thing. Fine. Now, one more thing I required here now. Rho also. That rho is nothing but what? Cutoff ratio. That rho is nothing but what? Cutoff ratio. Where I can get now? V4 divided by V3. So if once I know these all values, compression ratio, cutoff ratio, specific heat ratio, easily I can calculate the cycle efficiency. Okay, fine. Now when it is a compression ratio, right, that is RC is equal to V1 by V2. To calculate the compression ratio, the initial temperature and final temperatures will play a very important role. The initial temperature in the cycle is what? T1, and final temperature is T2. Okay, T1 and T2 will play a very important role in the calculating the compression ratio. And one more thing, as the compression ratio varies, the temperature is also going to vary. That's a very important thing we need to remember. Okay, expansion ratio. Expansion ratio is nothing but what? If you want to calculate the expansion ratio, I should know the value of cutoff ratio and compression ratio. Because compression somewhere else we are having compression ratio is equal to expansion ratio. So to calculate that expansion ratio, I should know the value of what? Compression ratio. If I want to calculate the compression ratio, somewhere I require cutoff ratio also. How it is, that we will see it in the coming steps. Okay, fine. That cutoff ratio, to calculate that cutoff ratio, we need to calculate the temperature at the end of the compression, and we need to calculate the temperature at the end of the expansion. So to calculate this cutoff ratio, expansion ratio, temperatures will play a very important role. How it is, that we will see step by step in coming slides. Okay, fine. So what is the determinant? Now I understood the problem. So what I need to determine here, dear students, first determination is I need to calculate the cutoff ratio, that is rho. Then I need to calculate the expansion ratio. I will mark it here RE, where RE represents expansion ratio, RC represents compression ratio. But in this problem is asking expansion ratio. Third one is cycle efficiency, that you can see now. To dear students, as I told, this schematic diagram will play a very important role to understand the problem thoroughly. Hence I have given this diagram. So you have to understand the problem with working of the diesel cycle. Okay, fine. Now I have taken the data and I have analyzed and I have listed what I need to determine. So okay, now what I will do, step by step I will solve this numerical. Okay, first step is what? I need to list out the given data that I have listed here now. Okay, what all things he has given? He has given compression ratio is 60. The initial temperature he has given 300 Kelvin and final temperature he has given, that is T4 is equal to 900 Kelvin, dear students. He is telling somewhere else, just a minute, I will come back to the problem. That is important here now. So now, dear students, I told compression somewhere else while reading the problem I told it is T2. No, it is not T2. He is telling at the end of the expansion. At the end of the expansion is started at 0.3 and it is going to end at a 0.4. Hence, what he has given, that's T 900 Kelvin is nothing but what? T4. That means what? T4 is equal to 900 Kelvin. That is nothing but temperature of the air at the end of the compression. Okay, at the end of the compression. That also he has given. I will mark it as a T4. Fine. Now I will solve this problem. So how to solve this problem? There are some important steps I need to follow. First, what I will do, I will try to identify the given data. Okay, as I told dear students, read the problem twice or thrice and try to list out the given data. Okay, fine. Then what you have to do in the first step, we need to calculate the T2, because T2 and T3, T4 will play as well as P1, P2, P3 will play a very important role while calculating the compression ratio, expansion ratio and efficiency and even work done also. Hence what I will do, I will calculate the all temperature and pressure step by step. So first, second step what I will do, I will calculate the T2. Then I will relate the T3 and T4 with the help of the PV diagram of diesel cycle. I will calculate the T3 and T3 I am going to relate with the T4. How it is that I will show. Okay. The next, if once you know the value of T3, that T3 I am going to express in terms of T2 and rho. Okay. Next step. Then after that, once you got the value of rho, that I will going to relate with what? T2 and T3 I am going to relate with what? T2 and rho. Then I will do simplification and I will try to calculate the value of what? Rho. Then next, I will calculate the expansion ratio. Dear students, as I told, there are two terms, compression ratio and expansion ratio. That expansion ratio I need to calculate. How to calculate that expansion ratio? We know the equation. That is nothing but what? V4 by V3. That also I will do. Okay. Next, after this, after calculating all the values, then what I will do? I will calculate the efficiency of the cycle with the help of a diesel equation. Diesel cycle efficiency equation, I can calculate the efficiency. Then at the final, at the last, I am going to represent all the findings in terms of results. Okay, this is the step I will follow. Okay, now first step. What is the first step? First my determination is what? What is my first determination? That you can see cutoff ratio, second one expansion ratio, third one cycle efficiency. To do this, what I am doing now, I am following these steps. I am following these all steps. Okay, in that what is our first determination? That is cutoff ratio. Okay, what is cutoff ratio? Step 1, I will try to find out the value of what? T2, as I told T2. Okay, how to calculate the T2? I will go with what? Isentropic compression process or adiabatic compression process. There we know the variation of temperature versus volume, that is nothing but T2 by T1 is equal to RC to the power of gamma minus 1. So what I will do now, I will try to take the value of T2 because T1 he has already given in the problem. I will try to take the value of T2 outside. So therefore T2 is equal to T1 into RC to the power of what? Gamma minus 1. T1 into RC to the power of what? Gamma minus 1. So then by seeing this equation, what I can understand here now? Okay, what I can understand now. So to calculate T2, T1 is required, RC is required, gamma is required. Gamma is required. Yes, T1 he has given in the problem, that is 300 Kelvin. I will take it as it is. RC also has given in the problem. I will write it here 16 to the 4 of what? Gamma. Gamma value is what? 1.4. That gamma for air is equal to 1.4. That is a constant. I will substitute minus 1. Then I will do simplification. I told you, dear students, how to do the simplification. Do simplification. Then you are going to get T2 is equal to 9.4 Kelvin. This is what? T2 value. Temperature of the air at the end of the compression. That is what? T2. Now I calculated T2. Similarly, I will try to calculate the other temperatures. I will go to the step 2. Then I will try to calculate the T3 and T4. I am going to relate it now. So we know the value. When it is an expansion process, right? We can write the temperature variations versus volume in terms of an equation. What is that equation? We know this equation, standard equation. What is that? T3 by T4 is equal to V4 by V3 to the 4 of what? Gamma minus 1. What is T3 here now? I will write it T3. I don't know the value of T3. I will keep it as it is. But he has given T4 value as 900 Kelvin. I will write it here now. Then V4 by V3. Dear students, in the cycle itself you can see. You can see now V4 is equal to, you can see when we are going to draw a vertical line, right? When we are going to draw a vertical line, V4 and V1, they are going to lie on the same point. That means what? In the heat rejection in diesel cycle, the volume V4 is equal to V1. So we know already this variation of temperature, that is V4 by V3. But what is V4? According to this diesel cycle heat rejection, V4 is equal to V1. Wherever V4 is the right, I will substitute the value of V1. So therefore what happens? V4, instead of V4, I will substitute V1 divided by V3 to the 4 of what? Gamma minus 1. So T3 by 900 Kelvin is equal to, now this I can write now. So it is whatever it is the right. So V1 by V3 I will express like this also. How I can express? So V1 divided by V2 into V2 divided by V3. Dear students, just you can see the same equation, this equation, I will write it in other form. This equation I am going to write it in other form. That means what? If once we get cancel V2 and V2, right? What we are going to get? V1 by V3. So V1 by V3 I am going to express in this way. So the same thing I have done it here now. So V1 by V2. So this is V1 by V2 into V2 by V3. To the 4 of what? Gamma minus 1. What is V1 by V2? That also we know already. That is RC is equal to V1 by V2. Then next V2 by V3. So we know already V3 by V2 is equal to cutoff ratio rho. If it is V2 by V3, then what happens now? It becomes what? 1 by rho. So the same thing I am substituting here now. So RC is equal V1 by V2 is equal to RC. The next V2 by V3 is there. But if it is V2 by V3, then what is the value of V2 by V3? That is 1 divided by rho to the 4 of what? Gamma minus 1. This is what? T3 value. But I didn't calculate the value of T3 here now, because rho is also unknown here and T3 also unknown here now. You can see at the left and right side. But two unknowns are there. I can't get the T3 value directly. I will go with what? Next step. Now I got the value of T3 by, now I got the value here, variation of T3 versus T4 versus T4, variation of T3 and T4 versus volume V4 and V3. I got this equation. What is that? T3 divided by 900 Kelvin is equal to RC divided by rho to the 4 of what? Gamma minus 1. Okay. Now, so I will keep this equation as it is. Now I will move towards next step. I will try to calculate I will express this T3 in terms of T2. How to express that T3 in terms of T2? Because when we are adding heat, right, that when we are adding heat rate, you are adding heat at constant pressure process. If it is constant pressure process means what? So P2, the pressure at point 2 is P2, pressure at point 3 is P3. So therefore we are adding heat at constant process, that is nothing but P2 is equal to P3, that is constant. If it is a constant, we know the ideal gas equation, that is nothing but what? V2 by T2 is equal to V3 by T3. So what I will do now? I will try to calculate the value of T3 here now. So therefore what happens? Do simplification. You are going to get T3 is equal to T2 into V3 by V2. So T3 is equal to T2 into V3 by V2. What is V3 by V2? That already I told you. V3 by V2 is equal to what? Rho actually. So therefore T2 into V3 by V2 is rho. That is nothing but what? T3 value. The value of T3 value is T2 into rho. Then what I will do now? I will substitute this T3 value in this equation. You can call, if you want, you can call it equation number 1. So I am going to substitute this T3 value in equation number 1. Then what happens now? You can see here, dear students. Substitute that T3 in in equation number 1. Then what happens now? So wherever T3 is there, right? So the T3, I will substitute T3 is equal to T2 into rho. Then T3 is what? T2 into rho. That I have substituted. T3 into rho divided by what? 900 Kelvin. I kept it 900 Kelvin is equal to into bracket RC divided by rho into bracket to the power of what? Gamma minus 1. So this is nothing but what? What is T2? That is very important. T2 somewhere else we have calculated in the previous step. Just a minute. Yes, T2 we already calculated, that is 909. The same value I am going to take it here now. So T2 I already know, that is 909.4 Kelvin into rho I don't know the value. I will keep it as it is, divided by 900 Kelvin is equal to, what is the value of RC? That is given in the problem itself. So I will write it here, RC divided by rho I don't know, I will keep it as it is. Then gamma minus 1, gamma is equal to 1.4, right? 1.4. If it is gamma minus 1, then what will happen? Now 1.4 minus 1. So gamma minus that value is nothing but what? 0.4. So the same thing what I'm doing here now, I'm substituting here 909 divided by 900 Kelvin. But don't confuse, this K represents what? Kelvin here now. There is no any other parameter or factor. So therefore 909 divided by 900 will be 10, just a minute. Okay, 1.0104 into rho is equal to 16 to the power of what? 0.4. Then rho, that powers is going to apply for 16 as well as rho. But here you do simplification, you are going to apply that rho. Okay, then do simplification, you are going to get the only one, you can see at the left hand side and right hand side, the only unknown is rho. Do simplification, you are going to get the rho value as 2.194. 2.19. This is nothing but what? Cutoff ratio. Does it have any unit? No. Why so? Because we know the definition. It is nothing but what? V4 by V3. So that means what? V4 it will be in terms of meter cube, V3 it will be in terms of meter cube, hence it is going to get cancels, hence there is no unit for the cutoff ratio. That is what? Rho is equal to 2.19. Okay, fine. Next step. Next I will move towards third step, that is expansion. First one I calculated. Next I will move towards next important parameter, that is expansion ratio. That expansion ratio I will mark here as a RE. So what is expansion ratio? As I told dear students, it is nothing but what? V4 by V3. So expansion ratio, what is the condition now? So we know already V4 is equal to V1. Wherever V4 is there, I will substitute V1. So that is nothing but V1 by V3. Okay, fine. RE is equal to this, I can express as I told dear students the same thing, V1 by V2 by V2 by V3. This is nothing but what? RC. This is nothing but what? 1 by rho. So expansion ratio is equal to RC value is 16, rho value is 2.19. So do simplification, you are going to get expansion ratio as 7.3. That expansion ratio is 7.3. That I have done, dear students, here now. So next what I will do now? Now second parameter is done. Now I need to calculate the cycle efficiency. To calculate that cycle efficiency, we derived an equation for a efficiency for a diesel cycle. What is that? That equation you can see here, dear students. Now 1 minus 1 divided by rho to the 4 into RC to the 4 of gamma minus 1 into bracket rho to the 4 of gamma minus 1 divided by rho minus 1. This equation we already know. Okay, substitute all the values. RC you know, gamma you know. Okay, again gamma is there, rho is there, you know all the value. Do simplification. You are going to get the efficiency of the diesel cycle as 0.6375. Multiply with 100, you are going to get 63 point, just a minute. Okay, 63.75 50%. This is nothing but what? Efficiency of the diesel cycle, dear students, for a given data. Hence, what is the final answers? You need to put a final answers in a square bracket at the end. What is that? First finding is our cutoff ratio. What is the cutoff ratio? That is 2.19. Second finding is expansion ratio, that is represented as RE, that is equal to 7.3. At the last, we need to calculate the cycle efficiency, that is neta is equal to 63.75%. Hence, like this we analyze the problem and we have calculated cutoff ratio, expansion ratio and cycle efficiency. Okay, this is how to solve the numerical. Dear students, I hope you understood this problem well. If you have any doubt, you can comment and you can ask. Here with I request you, please do subscribe my channel. Do subscribe my channel. Like and comment and do share. Your support will help me a lot. I request you, please subscribe my channel. Anveshana Academy. Thank you.